Mm-hmm.
Well, welcome to our Tuesday, March 22nd, 2022 Long-Term Water Supply Workshop, number 2. Roll call, please, Madam Secretary.
Director Coleman.
Present.
Director Katz. Director McIntosh. Here. Director Mellon.
Present.
Director Patterson.
Present.
Director Young.
I'm here.
President Lenny.
Here. We will begin with public comment on non-agenda items. If members of the public are online and wish to speak on agenda or non-agenda items, please use the raise your hand feature in Zoom. We will take the non-agenda item public comments before a presentation and the public comments after the presentation for comments on the presentation. When prompted, please state your name, affiliation if applicable, and topic. Please refrain from providing personal information such as addresses or phone numbers during public comment. If we need this information, we will have you contact staff. The Secretary will call each speaker in the order received. Each speaker is allotted 3 minutes to speak. However, I have the discretion to amend this time based on the number of speakers. The Secretary will keep track of time and inform each speaker when the allotted time is concluded. Do we have any speakers?
We have no speakers online for public comment.
All right. Board members will have the opportunity to comment and ask questions after each section of the presentation. And General Manager Clifford Chan will now introduce the workshop.
Thank you very much, President Liddy. Good morning to the board. Today is a continuation of our long-term water supply workshop update, which we started but were unable to finish on February 22nd. As we shared on February 22nd, we've continued to build on our water supply planning efforts over the years, and our portfolio has been tested, including through this current drought. Now, these droughts, as we shared, are being exacerbated by climate change, and we've also discussed the last time how new laws and regulations are placing pressures on our water supplies as well. Today, we'll start the workshop by responding to some of the questions from the board on February 22nd. Then we'll resume our update, starting with the discussion on desalination. At this point, I'll pass on to Mike Tognolini, our Director of Water and Natural Resources, to begin the workshop presentation.
Good morning, President Linney and members of the board. As Clifford pointed out, this is a follow-up workshop, a workshop number 2 from the original workshop that was held a month ago on February 22nd. We have a slide deck of 80 slides here, and we've already gone through over 50 of them. So we've got about 30 or so slides to work through and cover a number of topics. Do I have control here? Okay. So for our agenda today, last time we covered workshop goals and objectives and uncertainty within our supplies. We're going to finish up on our water supply portfolio update and then have some close it out with some closing statements. And I'm going to now go to slide 53. So I'm going to jump through everything we covered last time. And we're going to pick it up with covering a few issues that where the board had some questions. So let me get to slide 53. All right, there we go. So before we continue on with the presentation we had originally worked through in February, we wanted to cover a few follow-up items on water accounting, advanced metering infrastructure, dry year unit costs, and some more details about the East Bay Shore water quality technical evaluation. So as you can see from the diagram, we've already covered water conservation, water transfers, and recycled water, and then we're going to wrap up with the remaining portfolio, including Los Vaqueros, regional partnerships, desalination, and groundwater. And with that, I'm going to turn it over to Chris Potter, who's going to begin the follow-up slides.
Good morning, President Linney, members of the board. My name is Chris Potter. I am Senior Engineer in Water Supply Division, and I was invited to speak briefly about our raw water accounting. Water supply accounting has both a state and federal regulatory basis. State regulation is governed by the California Water Code for the appropriation of water. Recent state legislation that modified the Water Code has included SB 88 and SB 155. SB 88 went into effect in 2016 and added requirements for the measurement and reporting of water diversions. SB 155 went into effect last year and modifies the deadlines for reporting surface water diversions to the State Board. The federal regulation of Part E and Comanche reservoirs is through the Federal Energy Regulatory Commission, which manages our hydropower license and has oversight over the Lower Macomb River Joint Settlement Agreement. For treated water, the regulatory basis for our accounting is California Senate Bill 555. Our accounting methods follow the AWWA M36 manual, and my colleague Casey LeBlanc will provide more information on these procedures after my next slide. This slide illustrates our water supply system. The accounting for raw water is performed on a daily basis. Every day we track our network of weather stations and stream gauges for inputs into the system. And our daily accounting tracks aqueduct draft, the treatment plant influent and effluent rates, our releases downstream, and our evaporation from the reservoirs. This daily accounting is then published to the district's public website. Water supply engineering also performs a detailed review and verification of this data annually in order to publish our water supply statistical report, which summarizes an accounting of the entire raw water system. Thank you. Unless there are any questions about 55.
And so what we're trying to show here is when we talked about the distribution system losses, we want to start from the raw water system to say, here's how we account for the raw water, but when we get in the distribution system, it's everything that leaves the treatment plants, which you see in those pentagons over there, and and what our customers use. So it starts from the raw water, and then it moves over to the treated water system, which Casey will cover next.
And it's true that we can't actually count the inflow, correct?
We cannot measure, every inflow into the reservoir. So there is a balancing number at the very end when we do our statistical report of the things that we can measure, we include in the report, and the things we can't just balance out at the very end. So we don't know all the runoff into our reservoirs, into our watershed.
Okay. Thank you very much.
Good morning. I'll be presenting the district's process for its accounting of its treated water in the distribution system. And the district follows AWWA methods to audit its distribution system, and those AWWA methods split water losses into two categories: apparent losses, which are losses on paper. When meters get older, they under-register the water we sell our customers, and so that's a loss on paper. And then the real losses are losses we think of as leaks from pipes on mains and services. The district has been performing water audits according to AWWA methodology for 19 years, and that method is shown at the bottom of this slide. And it starts with the amount of water that is produced from our water treatment plants and entering into the distribution system. And that's this term here. We take that term and we subtract the amount that we sell to our customers, that total volume in a year, and we subtract it from the water entering the distribution system. And then the third term at the bottom of this slide is the apparent loss volume, which we determine by testing meters in our meter test bench, as well as testing larger meters in the field. And with those three numbers, we determine the real loss volume, which is the subject of the next slide, which will be regulated by California's Senate Bill 555. These first two terms are 20 times larger than the apparent loss volume. So it's really important that we get the water leaving the treatment plants right and the amount of water we sell our customers right. And thanks to the board for adopting a CIP in the last 2 years that includes a project to improve the accuracy for these first two terms. We are in the process of designing meter replacements for our water treatment plants, as well as replacing the meters for our largest customers. California's water loss regulation is called Senate Bill 555, and it was signed in 2015. The district at that point had already been doing water audits since 2003, so we had good experience with performing water audits on our distribution system. That first requirement of SB 555, annual water audits, did not have an impact on the district, but the second part that's shown on the slide, the real water loss performance standards, that may impact the district. And the State Water Resources Control Board has developed a mathematical model to calculate a regulatory limit for real losses for each of California's over 400 water utilities. The district has received a preliminary number, and through letters that we have written to the State Water Resources Control Board over the last 3 years, they have made adjustments to that model, and we're waiting on the state board's next steps with SB 555 with respect to if there will be another comment period related to SB 555, or if they'll move to adopt the water loss performance standards by the end of this year, which is what they have indicated. The performance standards are affected by the state board's model. It's a mathematical model, takes lots of inputs. If a utility doesn't have the data to support an adjustment to an input, then you use the default value. The district has requested adjustments to the default values because we do collect a lot of good data here at East EBMUD, and we've used that information to substantiate adjustments to our particular performance standard. The State Water Resources Control Board policy decision also affects the outcome of the performance standards. And then there are 3 example inputs to the performance, to the model, which do have a significant impact on the outcome. One of them is the infrastructure condition factor, which is based on the age of the district's pipes. SB 555 will cause utilities to come into compliance beginning in 2028. And so the district has been preparing for compliance with SB 555 in these ways. And the first is to improve our data quality. At the moment, the best information we have says that the district has a real water loss of 44 gallons per connection per day, but we don't know if that's the most accurate information available. So we are in the process of designing a project to replace the meters at our water treatment plants as well as at our largest customers. Once we complete that project in 2025, that will give us the most accurate information to date about our actual water loss. And it'll allow us to then determine how many resources are needed to comply with SB 555.
John,
The other
I have a question?
Yeah.
I have a quick question. So we estimated it's 44 gallons per day per meter per connection. Now, somewhere in here or in the staff report, our average customer uses 68 gallons per day. So is that 44 happening before the meter or after the meter? Because that seems like a huge amount when the average customer is using 68 gallons per day.
So the total water loss over the year is just divided by the number of connections in our service area. So it doesn't necessarily mean that every customer is losing that amount. It's a value that's average across all connections to our system.
So that includes what we get the daily update of the breaks where it could be 30,000 gallons and all that? Okay, thank you. I was going, wow.
Exactly right.
Plus, it's just like the average customer use. It's not, average doesn't mean anything. It's, there's people that use 20, there's people that use 2,000, and
Right.
presumably the more water you use,
No, I understand. I just
Yeah.
wanted clarification because I remember
Yeah, no,
somewhere in
that's
our
why I
report I
asked
saw
this-
68 gallons.
that's why I wanted this better explanation of what was going on, because it's a large number.
And we're not convinced that the 44 is the right number. So that's why we're implementing this project to get really, really good, accurate information about the water treatment plant flow rates, as well as our largest customers.
What's your hypothesis about what it's going to be? Or do you have one? Or
So the
guess?
meters that we will replace are non-mechanical meters, and so they can either over-register or under-register. So I don't have a guess at this point. When we replace our mechanical meters, the little small ones you saw on the other slide, those under-register. But that's been our ongoing program, and that does help bring up make our parent losses better.
We must have a fairly good idea, following Marguerite's point. We know how much water comes out of each water treatment plant on a daily basis. We see that in our reports. And we know what our sales are. So the delta is what our sales are versus how much is produced, isn't it?
Yes, and so we have meters that we believe could be improved for those two values.
The older ones in particular, okay.
The
Okay.
Phillips 66, the CNH
Okay.
sugars, the Chevron. So we're focusing on those large customers as well as the water leaving the treatment
Great.
plant, those
Thank you.
meters. These other 4 bullet points address real losses directly, and the combination of all these strategies have had the overall effect of reducing the district's real losses since 2017 in a downward trend.
So
we're
what
headed-
was it in 2017?
We were at 54.
Okay, so that's a significant number to help us understand what scale of change, we can expect, because that's a 1/3, decrease in losses, right?
Yeah. So as we do these projects, we suspect that our actual numbers, calculated numbers will go down, but that's why, Casey doesn't want to say one way or the other, but, these are difficult projects to replace the treatment plant effluent meter, as well as the meters in our large customers. Those are very large projects because you can't shut the customers down like a, CNH Sugar or a refinery. So we have to work with their operations to do that work.
And for my final slide, I'll be addressing a question from Director Coleman from the last workshop, and it has to do with our advanced metering infrastructure project. So the district is currently working with its consultant to prepare a business case for an expansion of AMI to other customers at East Bay MUD. So right now we have 5% of our customers with AMI, and this business case will look at some expansion to a portion or all of our customers with AMI to give us an idea of the costs. And then it's essentially a cost-benefit analysis that'll tell us what's the payback for doing AMI for more customers at East Bay MUD. We will be addressing federal and state funding. I've learned that through the Infrastructure Investment and Jobs Act, that's going to be distributed through the state revolving funds. The City of San Diego has been successful in securing $80 million in funding for their AMI project. So we will be researching their particular case and their application as part of our business case here at East Bay MUD to see if our application would be equally qualified. We'll have more to share whenever we have the findings from that business case, which are planned to inform the upcoming budget cycle this fall. Those are all the slides I have to present, and I believe Florence Weddington will be your next speaker.
Thank you.
Okay.
Florence, hold on because we can't hear you, and we had that issue with someone else trying to present offline. Give us one moment.
She's frozen.
Yeah,
Maybe she can come down.
Okay. Well, we'll have Linda Hu present this slide.
okay. Florence, Linda is going to present. Okay.
Okay, so we're addressing some follow-up questions from the board from the first workshop. First is the East Bay Shore technical evaluation. So the East Bay Shore Recycle Water Project, the pilot study that we're currently conducting is for the purpose of looking at water quality treatment improvements to reliably produce high-quality recycled water. We're evaluating different treatment alternatives, and the final recommendations are going to be available in 2023. And it is anticipated that these recommended improvements will increase the customer base for East Bay Shore. So I'll go into a little bit more detail on the scope of the pilot testing that's currently underway. First, we're looking at, as you know, the East Bay Shore recycled water has some water quality challenges. These are challenges that are above and beyond Title 22 public health requirements. We meet all of those. But we need to improve the water quality in order to expand the customer base beyond just irrigation, looking at indoor cooling tower uses and other types of uses. And also during droughts, as the water quality becomes more concentrated, some of the plant species that are sensitive to salts will require some salt removal in terms of the recycled water quality as well. So first off is salt removal. We're looking at partial reverse osmosis as well as full reverse osmosis treatment. We're also looking at ammonia removal that's needed in order to make the recycled water suitable for indoor cooling tower applications. So we want to evaluate breakpoint chlorination. We're looking at removing that at the main wastewater treatment plant. So that would be a centralized approach. We also are evaluating on-site or decentralized treatment at the point of use. And one of the technologies that we're exploring is Water Conservation Technology International, or sometimes you hear it as WCTI. That might be a technology that customers can implement in their cooling towers, especially for new developments that can plan on that.
So is that at the point of delivery or?
It's the point of use, so it's on-site at a new development site, for example. They would just look at WCTI. It's a different technology for cooling tower that works well with high ammonia and high salt water. We're also looking at alternate supply sources in terms of looking at the supply upstream before coming into the treatment plant, as that water quality could be better suited. And we are doing some water quality monitoring along the north and Adeline interceptors. And we're also looking at some advanced treatment to be able to take that flow and further treat it for recycled water use. So these are all things that we're currently exploring, and the pilot study that we're testing in real time is going to be completed, as I mentioned, in June of 2023. And at that time, we will have the plans for full-scale, the recommendations for full-scale implementation. Yes?
Are there peer agencies who have implemented recycled water projects for the types of customers that we're looking to be able to expand into, essentially large commercial office buildings or indoor use that distinguishes from the way we've been using recycled water previously? Are there peer agencies who have had success or non-success with some of the options that are under consideration?
Yeah, there are. I'll give you an example. So South Bay Water Recycling, which is run by the City of San Jose, coordination with Santa Clara Valley Water District, they do have recycled water customers, for example, cooling towers for the data centers down there. So they use a combination of centralized. So what they've done there is they've taken their tertiary treated recycled water and they run it through a side stream RO to improve the water quality and then blend it back in to lower the salts, and that's been used for those type of applications. We also, a couple of years ago, went down to see some of the on-site applications. Some of the data centers that planned it from ground one decided to go in with like that on-site WCTI technology. We visited a few data centers and on the South Bay, and they were able to use the recycled water successfully there as well. There's definitely challenges. Marin had a tertiary recycled water that they were using in for toilet flushing for some building indoor use, and they had some corrosion challenges, so they kind of discontinued that use, which is why we want to pilot different technologies to make sure we're successful in going forward.
And then Linda, on the alternative supply, so that would be basically not taking the water from the south receptor. Is that what you're proposing there?
Yeah, we're thinking like the north and Adeline, especially the Adeline interceptor is probably a better source water quality coming in. So we want to monitor that over the period of the year to kind of see what the seasonal trends are, and that might be a future opportunity to take that and run it through a separate treatment process in order to avoid to avoid some of the water quality constituents introduced at the treatment plant from, say, the resource recovery program, to allow both tracks to be optimized. So that's something we're looking at for the long term.
So Linda, when we're looking at doing this, we're talking about actually maybe having to put more infrastructure in, i.e. pipes and pumping plants, in order to do what you're talking about?
So we would need to put in, you mean regarding Director Young's question? Yeah, for that, That's something that we want to look at for not for the near term, for the long term. But yeah, that would involve looking at pumping plants, looking at additional piping, looking at additional treatment.
In energy.
And energy, yes.
So just to be clear, are we using recycled water for any indoor applications now?
Currently, we're not. No, it's primarily irrigation and some construction dust control.
I understand primarily, but are we using it here at all, or?
We're not using
No.
it in this building.
We
I thought we were.
piloted.
We did.
Yeah.
We piloted,
stopped?
but we found that we do need to improve the water quality.
Oh. Excuse me.
That's what I suspected.
Director Katz.
So this might be too, I don't mean to get too technical in this overall workshop, but I think for the study, I think it would be important to consider what the ultimate source issues are when you're looking at the alternative source, to understand what is it about the points that are contributing to that sense of an alternate supply source, and also I think to recognize the I&I issues that we're evaluating and controlling under the consent decree with the EPA, because as we limit the amount of I&I into the system, the constituent contaminants might increase proportionately. So, and that might correlate or not correlate with the supply decision. So I just wanted to suggest that review.
Sure, thank you. I made a note of your considerations, and we'll definitely do that, and we will continue to coordinate with the wastewater master plan as well, which I know they are considering looking at source issues as well as I&I, but we'll pay attention to those.
So, Linda, I think, Andy's point is important, but it seems, and maybe this test this assumption, is that it's true that controlling I&I will change the nature of the source in the times of year when that's an issue,
Yes.
which is a limited, this year, really limited period of time. And that, it may be that in, at least first storm events, that water isn't so great. It's full of oil, it hasn't necessarily, anyway, so I just think it's changed, but it's not necessarily more difficult or more challenging, because it's also both time limited and, right?
Yes.
So it
Depending
is
on the
important.
timing, yes.
Be better to figure out if we can capture the stormwater and do something with it. But that's not our agency, so.
All right. Yes.
I vaguely recall we did a pilot in a downtown office building for flushing.
Toilet flushing? Our
And
building.
we found out corrosion was an issue.
So our building. So you're. So we.
But it was another building also.
Yeah, I thought.
Yeah, I thought there was like some lead.
Right.
So we did pilot it in our own building years ago. I'm sorry?
I think it was Clorox.
No, it wasn't Clorox. It was.
No, it was a new building under construction, I think, that we had high hopes for.
I know the Shorenstein building.
Yeah, Shorenstein.
So
Yeah,
we didn't do a
they-
live pilot there, but the developer did go ahead and put in the dual plumbing so that when recycled water suitable quality is available in the future, we can connect them without having to retrofit.
Okay.
You might be thinking of that.
All right.
Okay.
Yeah.
Okay.
Are they plumbing any other buildings like that?
We are, when we have an opportunity to work with new development, we're asking them to dual plumb when they're within the East Bay Shore project service area. Okay, any other questions on East Bay Shore?
I also think it would be helpful for the next equivalent workshop to be seriously considering if this pilot study is looking like it will be successful in the future, to be carefully evaluating that service area of the project to see how we can evaluate expansion of the service area, to see if we can create longer service lines to be able to make the most use of it if we're going to have a successful project.
Thank you. All right, so I'm going to move on to the next slide. So This is as a follow-up to better explain the dry year unit cost calculation that we run for recycled water. So you can see the pie chart for our planning level, where we plan on the frequency of 3 out of 10 years will be dry in terms of the planning. And dry year, as you know, we have dry year projects that operate approximately 3 out of 10 years. Recycled water projects, we do run those every year. And our WSMP 2040, we looked at setting a standard for how to compare unit costs for dry year projects versus year-round projects. So that standard that was set in WSMP 2040 looks at taking credit for dry year yield in order to compare recycled water to other dry year projects. So what you see on the bar chart on the right is the unit cost comparison, dollars per acre feet. And you can see for every year, so for a 10-year yield, for example, it's 43,000 acre feet. Dry year will be the 3 out of 7 years will be the 12,900 acre feet. And then when you look at the capital cost, that's part of the unit cost calculation. Capital cost is 110 million. And then when you look at the annual cost, it's, for example, 5.7 million. So the unit cost expressed dry year, every year you can see at the bottom. For the every year, you take credit for all the yields you're running for that 10 years. So that's a lower unit cost. When you look at the dry year unit cost, you're accounting for the capital and O&M costs, but for the yield, you account for 3 out of 7. So that results, dollars per acre feet, that results in a higher unit cost. So that's, explanation of how we calculate unit costs for dry year in order to compare recycled water to other dry year projects.
Is it conservative to amortize the capital over 10 years, or should we be looking at a longer time frame?
The capital is amortized typically over a longer time frame. We typically look at, I think, amortizing it, say, over 30 years. Yeah.
Life of the bond.
I have to ask, is 3 out of 10 years for dry years has been something that we've used for the entire time, certainly I've been here, but I have to question whether it still seems like an accurate predictor of the
going into the future.
Yeah, into the future. Has there been any discussion about changing that or modifying that number?
We haven't changed it. That was the standard set when we did WSMP, but I see your point about, that was how we calculated before based on what we've seen before, and going to the future, certainly climate change, and there's other differences that we might want to rethink about how to do that in the future.
I agree.
Yeah, I don't know how much it would change things. I mean, even if you did it 3.5 or something like that.
It's hard to figure out what the new normal is going to be because it's so variable. So this is just an index of how we had compared it.
Yeah. Okay.
It's really about how often we have to import water, which might not change because the wet years seem to be wetter.
Dry years are drier, yeah.
And if our storage is, working, then we have the carryover.
All right, thank you. Okay, so next I'm going to hand it off to Brad Ledesma on desalination.
Good morning, President Linney and other members of the board. I got to say, I'm really glad to be here in person, get to see all of you face-to-face instead of virtually, so I really appreciate that. So we've gotten a lot of questions about desalination and how does that compare to recycled water. We thought we'd start with a little update about desalination itself. There are really two main technologies that are associated with desalination. One is thermal. Think of that as evaporation, and it just leaves everything else behind. The other one's mechanical. So what you're doing is you're taking water and you're actually pushing it through a membrane. And so the good water goes through and the reject comes back, and that includes brine and other things. The four big drawbacks for desalination are brine production, the cost, energy, and permitting. Of those four, the two main hurdles are really brine production and energy. So for brine, one way to reduce the amount of brine is to use brackish water. So instead of actually treating seawater, which has a much higher degree of salinity in it, you treat brackish water, which is lower. So you actually just produce less brine. But there's drawbacks associated with that, which I'll talk about in a minute. The other way to do it is use technologies that have larger recovery ratios. So most desalination technology is using reverse osmosis. So maybe use membranes that actually recover more of the water. So it produces less brine, but often it can have more concentrate in it. The 4 key ways of disposing, the main one is dilution and diffusers. And that's widely used throughout the industry. But there are some novel new ways that are being developed to dispose of brine. One is chemical conversions. If you've got the right kind of salt, you might be able to convert it into maybe sodium bicarbonate, which you can use in water treatment. Another way to do it is if you've got the right kind of salt, you can use it for aquaculture. So they'll actually take that brine and they'll grow algae that they can then feed the fish and do things with. And then the last one is just salt production itself. If you've got the right kind of salt, you can just use it to create normal salt. Now, the other big drawback is energy. So traditionally, these desalination plants can be connected to your grid, and depending on your power company source, that can contribute to greenhouse gases. However, as I'll talk about in a minute, there are desalination examples out there where they've linked it to renewable energies like solar, wind, and there's heat reuse options. The other way to do it is do energy offsets, where you invest in another, renewable energy project to offset any greenhouse gases you're producing. But it does provide additional costs and land footprint needs.
It's my understanding there's another way.
Oh, I'm sorry. Now you're unmuted. I'm sorry.
There's another way. And out in the lab, Lawrence Livermore, they've been working with it, and there's a company in San Leandro that's using it as well. And they use kind of a scouring pad type of thing, which has got electrodes attached to it, and the water flows through it, and by ionization, they are removing the salt. And that's being used, I understand, in Saudi Arabia and other places. And have we looked into that as part of our portfolio?
Not at this time, but we can look into it.
There's a company in San Leandro. You don't have to travel very far.
And if you need a contact at Lawrence Livermore Lab, I think Frank has alluded to that. I went out and saw several years ago what they're doing, and they're seem to be making huge advances.
Scott Perkins at the city of San Ramon introduced me to it.
Great, thank you.
And by the by, the use of the electricity on it is substantially less than the electricity that goes through the membrane.
Great, thank you.
What's the scale?
I'm sorry?
What's the scale? Is it bench scale, pilot scale? I mean, what
Yes and
volume
yes.
of water are they actually able to
My
produce?
understanding from Scott is that there's a full-blown project in Saudi Arabia, and the company, gosh, the name just slips me, but they're right here in San Leandro, and they are worldwide in their operation.
Great, thank you.
Before we go off to that,
Sure.
actually finish your presentation, then I'll deal. You only have a couple more slides on this topic, so go ahead and finish.
Thank you. Thank you, Director Coleman.
Yeah, I see that.
So often when you hear about desalination, these are the major countries you always hear about: Saudi Arabia, Israel, Australia, and the United States. We've got listed here sort of the reason why many of these countries have moved to looking at desalination. We've plumbed up the largest, capacity of the largest 5 plants. But there's Saudi Arabia there. We have a power plant that, a desalination plant that's powered by solar energy. Not 100%. It's a combination of both grid and solar. But they still do discharge to the Persian Gulf. In Israel, they have the Sorek desalination plant, which is powered by natural gas. Again, that discharge is still, the brine is discharged into the Mediterranean Sea. In Australia, they have the New Wales Sydney desalination plant. They actually invested in wind energy that meets 100% of the needs and more of that desalination plant. And then in the United States, the one everyone hears about is the Carlsbad desalination plant in San Diego. So in that one, they actually have energy recovery devices. So within the process itself, they're able to recover some of that energy and then reuse it. That brine is actually diluted with seawater and then goes out into the bay. Let's take a look at what's going on here locally. So many of you probably heard about the City of Antioch brackish water desalination plant. That's about a 6 MGD facility. It uses reverse osmosis. However, for brackish water, unlike seawater, you have to tie it to a water right. You actually have to have a water right in order to support that facility. So City of Antioch actually has a pre-14 water right they're able to use to run that plant. They're using conventional grid. They dilute the brine. It's about $1,000 to $1,300 an acre foot. Another effort that has been going on for several years is the Bay Area Regional Brackish Water Desalination Study. So here's some results from a study that was done in 2013. The current leads on that project are Contra Costa Water District, San Francisco Public Utilities Commission, Valley Water, and Zone 7 Water Agency. East Bay MUD is part of that group, but more in the line of wheeling for the other partners. The capacity of that plant is 20 million gallons per day, reverse osmosis. But the key drawback is the source water for that effort is currently a post-14 license and permit, which means that it can be curtailed during droughts, and that makes it very problematic. The energy can be offset with greenhouse gas projects like solar, not greenhouse gas projects, but renewable energy projects like solar energy. The brine would be diluted, and the cost, including that offsets, would be about $1,400 to $1,800 an acre foot. Now, looking at seawater, you have Marin Municipal Water District did a study several years ago where they looked at about a 1 to 5 MGD plant at about $3,000 to $4,000 an acre foot. But just to reiterate that they actually are getting ready to embark on a new study. We'll probably be looking at this, and this is a really small scale. So to put that into perspective, like Carlsbad at 50 MGD instead of 5, which is 10 times larger, it's about $2,400 to $2,700 an acre foot. Now let's compare these unit costs to the cost of, let's say, recycled water.
Excuse me, how come the Marin one seemed to be so much more expensive? Is that because it was a smaller capacity, or did they have other?
It's seawater. So they're having to treat very, very high salty seawater. We're talking 30,000, 40,000 milligrams, versus brackish water, which could be 6,000.
And the bay water is considered seawater.
Correct.
Right. Okay.
So let's compare now the cost of desalination to recycled water, which is often asked. So on this graphic on the y-axis, we have the total unit cost in dollars per acre foot. Then on the x-axis, we have every year water and dry year water. And then we have several types of projects. So the first two are recycled water, it's non-potable reuse, and then potable reuse. And then we have desalination with brackish water and desalination with seawater. And then we do the same thing for dry year water. The circle being filled in means that's an existing supply that the district has already developed. A empty circle implies that that's a future supply that would need to be developed. And the size of the circle represents how much yield would potentially be available for that project. And the key takeaway here is that brackish water is fairly similar in unit cost to, let's say, non-potable reuse or potable reuse. Desalination of seawater might be a little bit more expensive or on par with potable reuse. But when you look at the dry year side, I just want to reiterate, if you look at the brackish water, it's subject to curtailment. So unless that project is tied to something like storage or something like that, that desalination plant would not provide supply during a dry year. So we are currently focusing on other water supplies that offer lower cost, lower energy use, and lower carbon emissions. We're going to talk about some of those coming up.
Now I have some questions. First, I'm going to go to slide 65 deck. How much does the city of Antioch have pre-1940 water rights to? It says they're going to be doing 6 million gallons a day. So what is their water rights that they're allowed up to?
I don't know that, but if we were to convert that to acre feet, it's probably in the 7,000 acre feet range, but it probably depends on, their water right itself, like when they can take it, diversion times and all that.
You'll see where I'm going to go, but I think I would like to know that because that may provide an option potentially, because I thought the Bay Area project that was talked about was being placed in Antioch, if I would remember correctly, the 2013 regional brackish desal. Wasn't that where was it going to be done?
At one point, they were looking at it being in the city of Antioch, but now it's at the Mallard Slough intake for CCWD.
Okay.
And it's tied to post license and permit that are actually owned by CCWD.
Okay. Well, again, I'd like to know what the water rights are for the city of Antioch pre-1914, and they may not be exercising the full amount, which could be actually a project if we're going to go down that road. And the other thing I think that we need to look at, if we're to go in that direction, yes, it's expensive, but when you're looking at $1,400 an acre foot compared to some of the things, previous slides, it's actually not super expensive if it can go in large Los Vaqueros, for example, during the periods and water trading. But going back to slide 63, I would really like to see an apples-to-apples comparison, because we're not seeing that even on the last slide that you showed. The energy used for desal versus recycled water. And not to say, I'm a firm believer we should do recycled water. I'm there. But I want to see a slide, actual cost on the different variables of energy for the two. And I asked the question earlier when we talked about recycled water, how we may have to do another line and pumping plant, because recycled water cannot commingle with potable water. We all know that. And we never talk about really the capital cost, to me, explaining all the pipes, the construction, the ripping up of the streets, the pumping plants, or the storage reservoirs. Those are all separate from our potable supply, whereas recycled or desal can go right into it, and so you actually have less infrastructure except for the facility where you're building the plant. And we don't see that as apples to apples, so I want to see that in terms of pipelines, pumping stations, and tanks. And then I applaud you on the different ways of potentially getting rid of brine. I think that's encouraging. I think what Director Mellon brought up was appropriate in terms of looking at what Lawrence Livermore Lab is doing in the facility in San Leandro. And, you know, I would also, when we look at slide 66, it looks nothing like slide 61. 61 is easy to look at, dry year, wet year, per acre foot cost. I would like to see side by side, not circles that you can't really, to me it's hard to visually look at that and see what the costs are. I know that there are obstacles. I think firmly if we're going to go in that direction, we should be a goal of 100% energy neutral. And when we talked about at one point up in Antioch or Pittsburgh or Mallard Slough, there was discussion of on the islands, which has a lot of wind, of doing wind turbines. And that would be, to a large extent, it also is open land where you could do solar facilities. And the price would be dropped dramatically if you're able to go net neutral in energy in the total cost of per acre foot. Those are some of the things I would like to see. We're not going to make a decision on this today, but I get asked a lot, why aren't we doing it? And I tell them, well, this and that, and they go, that's BS, is what I hear. And I need to know the facts in order to say yes or no or why when asked these questions. Side by side, again, we should do recycled water. We should do more if we could, quite frankly, because we know with climate change, the demand is going to be, we're not going to have as much water coming into our system from the Sierra snowpack. We need to come up with other supplies. And I think desalinization can be, if it's energy neutral, and we figure out the brine disposal and the cost per acre foot, it could be an option. But we always sort of dismiss it. That's my perspective. I don't know where the board members are coming from, but I want to see apples for apples comparison, if we can. And I know we can.
All right. Questions, Andy, and then Frank.
So I'm left to my imagination on what the cost effectiveness is for desal of brackish water in a dry year. My imagination says it's multiples higher than what fits on the chart, but some verbal context would help, because that the curtailment does seem to be a major issue, and the fact that it's only serving 3 or so out of 10 years is a major issue. But what was our back of the envelope estimate in the absence of putting a number on the chart?
It would be about 3.3 times higher. So instead of it being around 14 to 1,800, it'd be 3 times that.
Frank?
I seem to recall on the Bay Area Regional project that where it was situated was halfway between 2 wastewater plants, or sort of, and we were taking the brine and shipping it over to the discharge so that it was maintaining the ecological balance of the river at that point, because that's where they ran into problems in South Bay. Their discharge of wastewater was turning the South Bay into a freshwater lake. So, but this, I don't know what to call it, this block doesn't indicate, it just says diluted. I think noting that it's diluted by virtue of using a wastewater discharge and having an ecological balance, because I went to the Sierra Club's presentation on this back then, and they had a problem disagreeing with the project. They flat out said it, because the brine issue was taken care of, and the only thing they could come up with that was bad about the project was the energy use. Everything else, and this was a large group meeting, Doug, and I was blown away, because up to then, they'd been no on everything. So that, and I'm wondering if that issue of having a disposal like that for the brine in that fashion lessens the costs any.
Yeah, I believe that those costs that were presented in 2013 actually accounted for that. We probably could have done a better job in explaining it as diluted with discharge and ecological balance.
Okay, thank you.
You're welcome.
Other questions? Marguerite?
Yeah, I mean, I continue to have, the cost figure is the one that makes me think that there's other things, but that we aren't doing, that could also be looked at, that we haven't looked at. And I'll bring up my favorite one, which is that, and it wouldn't solve the recycled water problem. It would actually make the recycled water problem worse, because we'd be using less water that goes down the drain, which is, well, it's not just gray water. It's expanding gray water, but it's also, looking at the fact that we still surround every flush with, 1.6 gallons of water, instead of going to, looking at or helping to advance the conversation around dry toilets and the like, which will never be fully adopted. I get it, but Australia, we point to Australia and what they're doing, and Australia certainly has moved the needle on that topic, and that's a big potential supply of water that we're not using. So I think are there other, and the other one that comes to mind, and there's a disconnect because it's not in our purview, is stormwater.
Another thing, actually Marguerite brought this up several years ago, and I thought, oh my gosh. It was to put recycled water in a storage reservoir, whatever, let's say hypothetically Briones. And I thought at the time the concern was with the public perception, but I think perception may be starting to change. So if we can, if the board is so interested, I would like to see that analysis again. I know it's expensive, but again, it may be an opportunity where we're not talking 3 out of 10 years. The other benefit is if we're able to keep our local reservoirs fully, and that may be offset some by some of the Freeport cost, I don't know. But if we're able to keep our local reservoirs full going into a drought and in a drought, that gives us greater opportunity as the state and federal government comes in and says, this is what you need to do for the habitat on the rivers. And I think, this is a shift for me, but I think we need to really reevaluate how we can do that, because we clearly, the state and we're going to have more droughts, it's going to be more severe, and the state and feds are going to say you have to put more and more water into the river. And there's not a whole lot we can fight it, but it's being chipped away at, unfortunately. And I would like to perhaps see that evaluation again. I don't know if other people think that or not.
It was presented last month.
Oh, I guess I missed it. I'm sorry. But did we talk about it much?
We can, we can.
It was really expensive.
We can share those types of concepts that we've discussed before, maybe in the follow-up memo.
Okay, I apologize if it was last month. I looked at the stuff from what's today's going forward. I think it was slide 50 or something.
Yeah, it's 48 and 49.
Should have started earlier in the deck. But I think whatever. My perception of what we may need to do is evolving to protect our customers and our water supply for business, industry, and homeowners.
We can do that, and we can also share some of the pros and cons that we've looked at with those options. There are some significant drawbacks as well.
Yeah, I know. I don't want to see people buying bottled water as a result, which comes from us if it's Safeway water anyways, and then they pay through the nose as a result.
Okay.
Other questions? I have one question. I'm just trying to better understand the every year versus the dry year costs, and the so when I've gotten questions about why aren't we using desal, my answer has generally been, well, we would only be using it in the dry years, and that makes it much more expensive. So, is there a case to be made that we would use it every year, in which case it would be, in fact, cheaper, or how does that figure?
There could be a case to be made, but we would have to look at that.
Mm-hmm.
And if you do operate it all year, every year, you would take credit for that supply. But depending on what the future hydrology looks like, you may not need it. And so the question becomes, how do you balance those two, and how does that look like from a unit cost perspective? I see what you're looking at.
Unlike performing a sensitivity analysis with recycled water or another type of supplemental supply, where it might look more attractive if we expand the number of dry years assumed, the curtailment years would probably increase proportionately. So the performance of a brackish desal may not improve, although the seawater desal might.
But so when we're talking about desal versus recycled water, the recycled water we use every year, and the desal, we're likely, if you're looking at the cost comparison, looking in the second half of this chart.
Right, and if we did brackish desal every year and didn't do it in the dry years because we couldn't do the curtailments, we'd still have kept, because we have our own supply, we'd keep that much water, in storage, or in the reservoir, right? So.
And that would be the key, is to be able to link that brackish water supply to some sort of storage where you can capture, use it, use that water in the non-drought years. So that way, when you got it in storage for the drought years.
But again, this is fairly complicated, because even if you can go into 1 year and with say brackish desal every year, as you get into multiple years,
yes.
Because we can only keep our reservoir so full without the risk of spilling. So it helps you as you go into a single year, but if we experience multiple years, we need to look at things that we can run multiple years. And even with desal, with some of the technologies, you can't, especially with membranes, you just can't start and stop the facility. It has to run all the time. So you're taking on that expense every year, even when you don't need it. And so what I hear from the board, and I do want to mind the time and make sure that we cover the other topics. But what I'm hearing is just to take a deeper dive in the comparison of these various options, to make sure that we haven't missed anything in our analysis, and to report back to the board on that. So we can do that.
All right, thank you.
Moving on. So the next project or update we want to provide is on the Los Vaqueros Reservoir project. So this is a project where Contra Costa Water District is working with several other agencies to expand its reservoir by 115,000 acre feet for water supply reliability, water quality, and to support one of the largest wildlife refuges in California. In October of last year, the 8 members we've listed there, voting members, formed a JPA, a Joint Powers Authority, of which East Bay MUD is a member. The current costs of the project are estimated about $940 million. About half of that is grant funded currently through a California Water Commission grant. Currently, the district is evaluating whether to secure up to 30,000 acre feet of storage in Los Vaqueros. The estimated cost in capital dollars is 50 to 100 million, and that really depends on grant funding. And then the estimated dry year unit cost is about $600 to $2,000 an acre foot, and that's dependent on the supply source. So is it our existing supplies? We have to purchase water. How would we participate? One way is through storage, obviously, and we are looking to use a combination of existing supplies and water transfers to fill the district's allocation of Los Vaqueros, including the use of recycled water credits through Water Code 1010. And then in addition to storage, the district may also wheel water for the partners using Freeport when Freeport's not being used for the district's customers. Moving forward, the district staff and the JPA will be working to negotiate several agreements, which we have listed here. It'll take about 1.5 to 2 years to do that. During that process, we will be refining the costs and benefits to the district. And within that JPA, there are withdrawal clauses or off-ramps, which allow us to exit the JPA if we were to determine that the cost was not beneficial to our customers. Looking at the schedule, this schedule goes through 2030. The first bar going across the top, you can see that's this JPA and starting the negotiations. East Bay MUD has its own project, which is a Walnut Creek Variable Frequency Drive project, which is needed to wheel water for the partners. But that third bar you see there, that's the one I want you to focus in on, Los Vaqueros Dam expansion. What you can see is the dam won't be completed until around 2030. And this is the current schedule. It's likely to change depending on what goes on, how the negotiations go. All those facilities you see below that, the pumping plant, one replacement, Neroli, transfer Bethany pipeline, all of those are being scheduled ahead of time because they need those facilities in order to, one, drain the dam, and then also help CCWD provide supply when Los Vaqueros is actually out of service. So I'll stop there. Any questions on Los Vaqueros?
Okay.
Great. So the next item is groundwater. So let's start with local groundwater, the East Bay Plains Subbasin. In December of last year, staff brought to you the groundwater sustainability plan for the East Bay Plains Subbasin. That was adopted. Staff submitted that to the Department of Water Resources in late January of this year. Staff is now moving forward with collecting level monitoring data, groundwater quality data, surface water data, and subsidence monitoring data to help fill data gaps that were identified in the groundwater sustainability plan. And those data gaps will be used to drive science-based solutions moving forward, and in particular with respect to better understanding groundwater-dependent ecosystems and links that they have in the East Bay Plains Subbasin. As presented back in December, the implementation costs were estimated at about $2.5 million over the next 5 years. The other local groundwater project is East Bay MUD's Bayside project. This project was completed in 2009, has the capacity to inject about 0.3 to 0.5 MGD, and can extract up to 1 million gallons per day annually over an average that's over 12 months, or 2 MGD over 6 months. In 2017 through 2019, we had surplus water years, so we were actually able to recharge 18 million gallons into the East Bay Plains Subbasin. If the district were to secure approvals, we would be able to extract water from the East Bayside facility to support drought operations or an emergency. In the past, those approvals have not been sought due to completion of Freeport. New data that's going to be collected as part of the groundwater sustainability plan will be used to help guide future extractions and expansions of Bayside. The other groundwater project we have is a non-local groundwater project. It's the Demonstration Recharge Extraction Aquifer Management, otherwise known as DREAM. This is a pilot project that we are doing with San Joaquin County, North San Joaquin Water Conservation District, and the Eastern Water Alliance, where East Bay MUD would release water that the could be used to replenish the critically overdrafted Eastern San Joaquin Subbasin. And in return, East Bay MUD would be able to secure a dry year supply. For this pilot, East Bay MUD is working towards releasing 1,000 acre-feet with the ability to extract up to 500 acre-feet. The first schematic you see on the left there for recharge, you can see what we do is we release water from Comanche. And essentially, it makes it through a series of existing facilities and ends up being used at a farm in San Joaquin County. For extraction, just for this pilot, there's a well K13 where we would extract water, and then through new facilities, you can see that's a 2.8-mile pipeline that was just recently constructed by North San Joaquin, and then a pumping plant and facilities to actually put that water into our McCollum Aqueduct. Through a permit that the district has from San Joaquin County, we have the ability to move water, only extract water from October 1st through March 31st. The schedule you see here was the schedule as of workshop number 1. We have completed construction. However, we're unable to do the startup testing before March 31st, which was in correspondence with our permit, so that will wait until October of this year. And that was due to pandemic-related supply chain issues to get our pumping plant. We lost the month of December due to rain. There are a myriad of different issues that led to that. So I will stop there and ask if there are any questions on groundwater before I move on to the last topic, which is the Bay Area Regional Reliability Partnership.
Well, the pictures look so real. It's, pinch me, I'm awake. It's really exciting because this has been decades in the making. Refresh our recollection of, assuming the pilot goes successful, how, if every, landowner, potential groundwater bank participant were amenable, what's the potential of this in terms of banking and recharge?
We're actually working with our partners to evaluate that now and see what that might look like. In the WSMP 2040, I think they estimated around 20,000 acre-feet, somewhere around those lines, in terms of drought year benefit for the district.
Thanks. And in terms of converting that to our potential availability of MGD?
Let's call it, let's see, that's 10, 20, so call it like 18 MGD, something like that.
Thanks.
John, did you have a question?
No, I just pointed to Andy.
Oh, okay. Bill, do you have a question? I wanted to ask, I'm sorry, going back to the Bayside project again.
Our favorite.
Yeah, no, I'm sorry. It's answered here. I didn't notice that. Thank you.
Okay, moving on to the Bay Area Regional Reliability Partnership, or BAR, is what folks like to call it for short. This is a consortium of Bay Area agencies working together to figure out how can we share resources to improve the resiliency for the entire Bay Area. Currently, BAR is focused on something that we're calling the Shared Water Access Program pilots. So we recently completed a drought contingency plan. As part of that plan, it identified new facilities and things that could be used to help share resources. However, what became really clear was that what are the institutional hurdles that are needed to actually share that water? What are the agreements? How do you move it in? How do you get it out? And so we moved forward under a grant with the United States Bureau of Reclamation to identify and look at 3 different pilots to test that particular institutional arrangement. So the first pilot is really about how can we take water and exchange it between 2 agencies with 2 different sources and up to 20,000 acre-feet, using, let's say, Los Vaqueros as a way to sort of park that water. The second option is really, can you take non-CCWD CVP supply and actually put that into Los Vaqueros and then move that out up to 5,000 acre-feet? And the last one is a test of how could, for example, East Bay MUD take delivery out of Los Vaqueros using Freeport using an exchange. So all 3 of those pilots have been completed, and the partners now are working on taking what we've learned from that and putting it into a final, swap report that we are then going to be vetting with our task force, and then that report should be ready by January of 2023. Any questions on BAR?
I just have a question. I can probably figure it out. For 1,000 acre-feet, about how many million gallons a day it is it? Just so when I look at things, it says up to 20,000 acre-feet. How many million gallons a day is 1,000 acre-feet?
Don't know off the top of my head.
About 325,000
Gallons.
gallons per acre foot.
Right.
Okay, thank you.
Any other questions?
Per acre foot, not
Per acre foot, so times
no.
1,000.
Yeah.
So times 1,000. So it's
325 million.
Okay, thank you.
Any other questions?
So we have existing supplies. They're doing well, but we're not there yet. We need to continue to build resiliency through diversification, and you can see what the district staff's working on now: recycled water, transfers, conservation, groundwater, desalination, regional partnerships, and storage. Meanwhile, if we do have an issue, we do have the water shortage contingency plan, which will help address those issues, and that plan is updated periodically by staff. So with that, I'll open up for board and public comment.
Any other questions? Any public members of the public who?
There is no public comment. We need to check the audio because when Florence and Barry came on, we could not hear them, but people in the Zoom meeting could hear them. So we need to check the audio once this is complete so that we can receive public comment. But we have no one online right now.
All right. I just want to applaud all of you. This is great information. Thank you very, very much. I asked my questions, but kudos to all of you putting this together. Thank you.
I just want to second the request for a little bit more information in the future about stormwater. It seems, while it's not under our purview in terms of water rights the way the McCollum is, we have never been shy to seek partners. And while there may be challenges with water quality and permitting and such, we should still monitor what are the options and consider that for future workshops.
Any other comments? Great.
Thank you.
So let me just, President Lenny, do you have anything else to add? Okay.
No, I just join with John and say this is great. I do like workshops because it gives us an opportunity to ask questions as we go along, to increase our understanding, to also give staff some feedback on things that we have particular interest in or have particular questions on. And I thought this was helpful, and helpful that we had it in two phases, so we had enough time to cover everything.
Okay, and I just want to quickly summarize what I heard from February 22nd and what I heard from today. First is, just to ensure that our plan is consistent with statewide solutions to improve water use efficiency and protecting the environment. Consider the cost to our customers. This was something that brought up, and how our plan can create a reliable water supply with things like water conservation while balancing that with our finances. Continue our efforts to address our own water losses. And then much of the discussion I heard today was, to investigate things like recycled water and desalination, make sure we have that apples to apples comparison to share with the board, and look at other sources, as Director Young and Director Katz talked about, stormwater, rainwater, dry toilets. Really, I think what I'm hearing is see if there's something that we missed, as well as look at changes in some of our underlying assumptions with regard to the frequency of droughts, or maybe how the rain is changing with these extreme weather patterns. Maybe that might affect our planning. So we will do that and report back to the board.
Great. Then with that, we will close the workshop.